Okay, you guys, so now that we've gotten used to or been introduced to function notation, let's go and use it. So I've got a couple of situations with lots of problems, lots of different things going on, but I'll probably do the first one in one video and the next one in the other, if that works out, or maybe we'll break it over 2 or 3. But a lot of good information here. So for starters, our function f is defined to be this quadratic, x squared minus 2x. And so we're going to go do some things functionally with that. So if you'll notice in the first round here, right, the 4 is in the parentheses. So that's my way of telling you that x is equal to 4. Our job is to basically find the y value. Easy enough. We just do what we've done in the past. I go to my expression and I replace the x with 4. And we end up with 16 minus 8, and it looks like we get 8. So f of 4 is equal to 8. All right. If we were graphing this function, I now know that 4, 8 is actually a solution point on that function. If x is 4, the output's 8. And it's behaving like a function, right? One thing in, one thing out. Same thing here, right? Negative 3. Well, notice where it's at, right? It's inside the parentheses. So I'm telling you that x is negative 3. What is the corresponding y value? So I think we get 9 plus 6. Looks like we get 15. So f of negative 3 is equal to 15. All right? And again, on a graph, when x is negative 3, the y is 15. So we now know a location there. And last one for this cycle, right? X is equal to 0. Plug that in. Right? We get 0 minus 0. We get 0. So f of 0 equals to 0. All right? Or meaning that my graph, when we do graph this, has the point 0, 0 on it. And quite frankly, we've also found the x and the y intercept. Okay, relating x to something else. So for that cycle, for A, B, and C, I let x equal a value, and all you have to do is plug it in. How do I know x is the given? Because it's in the parentheses, right? That's where our independent variable is. All right, f is the name of the function. It depends on x. So what's the value when x is 4? What's the value when x is negative 3? What's the value when x is 0? So forth and so forth and so on. Okay, so the next stanza, D, E, and F, all right, we start getting a little different, right? There's not a number to work with, all right? But just keep following our little song and dance. So here's A, and it's inside the parentheses. So I'm basically telling you x is equal to A. So I'm going to go to my function, and wherever I see an A, or excuse me, an x, I'm going to replace it with A. So f of A would just be a squared minus 2a. And that's it. That's about all I can do. Right? What about f of negative x? Well, here, right, what we're doing is replacing the x that was in the parentheses with a negative x. And so all I got to do is go to my function and replace my x with negative x. If we clean this up, whether I have a positive or negative, right, negative x squared is the same thing as x squared. Here we have a negative and a negative. That'll be a positive 2x. So there, right, is f of negative x. Looking ahead, we've noticed, remember symmetries when we replaced x with negative x? And if we got the same function back, we would know if we're symmetric about the y-axis. Well, this one's not, right, because that clearly is not the same as that. So looking a little bit ahead there, but that's kind of relating what we just did to a previous topic. For now, right, we're just replacing the x with its negative counterpart, its opposite. Plug it in and see what happens. Now, f's a little different. Take a look where that negative is at, right? The x is itself, right? F of x is here, and we got that. And remember, what f of x represents is y. So we're taking whatever y is, and we're putting a negative in front of it. So what is f of x equal to? Well, f of x is x squared minus 2x, right? And I'm putting a negative in front of it. So there's your negative of f of x. So we're actually not putting anything into the function. This negative is actually impacting or applied to the whole function in its entirety. And so cleaning this up, distributing, we get negative x squared plus 2x. Okay? And there's also a symmetry discussion there, right? Because we replace y with negative y. We're talking about being symmetric about the x-axis. And clearly we're not, because that's not the same as that, but I'm looking ahead. So be careful where things are placed. Inside the parentheses, it's impacting input. Outside of those parentheses and affecting f of x, it's impacting y. Okay? G, here, notice that the x minus 5 is inside the parentheses, so we're basically replacing our x with x minus 5. So what do we do with the input? Well, in this case, what we do is we take that and we square it, and we take that and multiply it by 2. So I'm just replacing the x with x minus 5. It's in the parentheses, so it's impacting our input. Cleaning this up, we would have to FOIL this part out, and here we would distribute. I think we get that. FOILing this out, I think we end up with x squared minus 10x plus 25 minus 2x plus 10. And so cleaning this up, we get x squared, it looks like minus 12x and plus 35. So there would be f of x minus 5, all right, given the function that we're currently working with. Change the function, we'll change that value. But if I replace x with x minus 5, I obviously have a different function. Okay, same thing here, right? What we're doing is replacing, this again is in the parentheses, so we're replacing x, right, with 5x. So I'm going to go to my function, and wherever I see x, I'm going to replace it with 5x, because that's what I'm being asked to do. And cleaning this up, I think we end up with 25x squared minus 10x, right? So there's f of 5x. And what that equals to, it's a different function, all right, because we've manipulated the input by multiplying the input by 5. Here's something that's a little odd, right? We have x plus h. So again, look where it's at though. It's inside the parentheses. So essentially, I'm replacing my x with x plus h. So for the function f, we're going to take that x plus h and we're going to square it, and then we're going to subtract 2 times it. So we're replacing x with x plus h. Cleaning this up, I believe you'll FOIL this out, and when you do, you end up with that perfect square trinomial. Do distribution there, and there's really not too much to clean up. There's no like term. So that's the train wreck we get if we replace x, right, with x plus h. All right, and that'll be important for us next week when we talk about what's called the difference quotient. Okay, the next one looks a little difficult, all right, but we have f of 3 minus f of 1 all over 3 minus 1. So the bottom is not too bad, right? That we know to be 2. But upstairs, before I perform that subtraction, I actually have to find what f of 3 is, right? Remember, that's an output when the input is 3. So off to the side here, what's f of 3? Well, from my function, right, that's 3 squared minus 2 times 3, and 9 minus 6. That gives us a value of 3. Okay. What about f of 1? F of 1, 1 squared minus 2 times 1, 1 minus 2, we get negative 1. So we end up with 4 over 2. That evaluates out to 2. So that crazy expression, right, is 2. And giving you a little bit of inside information, you just found what's called the rate of change, or what you guys know to be slope. y2 minus y1 divided by x2 minus x1, right? So that's technically what we just did there, but there's your flow. I have a function value to find, subtract it to another function value to find, and then on the bottom we just have a subtraction. Find all the information, then do your work. F of x equals 0 for k. Now again, be careful about who's equal to 0 here, right? This 0 is not in the parentheses like it was there, right? So I'm not letting x equal to 0. I'm technically letting y equal to 0. So I'm going to go to my function, and I'm basically going to set it equal to 0. So we now have an equation to solve, right? What inputs create an output of 0? So perhaps we do a little bit of factoring, use my 0 factor property, and we find out that those are the 2 values. And easily checkable, right? 2 squared is 2, minus 2 times 2 gives us a value of 0. So these are the two these are the 2 inputs that create that output of 0. So again, I gave you y, you got to find x. Up here I gave you x, you got to find y. So be careful about the placement of your number. Inside the parentheses it's impacting x, and outside the parentheses it's impacting y. Okay? So what about this last one? We have f of x equals 8. Well, again, this is just a fancy way of saying that y equals 8. My function is x squared minus 2x, and so I got to figure out when exactly is that equal to 8. So what inputs create an output of 8? We subtract 8 from both sides, and we get x squared minus 2x minus 8 equals 0. This one also factors, I believe, right, using some previous knowledge. We get x minus 4 equals 0 and x plus 2 equals 0. Adding 4 and subtracting 2, we get x equals 4 as an input and x equals negative 2 as an input. And so there you have it. So there's our first round of function notation. We're in 11 minutes into this. How about I stop there and we redo that with another example with another function, maybe one a little more complicated because it's got a square root. And I'll see you guys in that next video.